Okay, so these are some discretes. This is final few discretes we're going to get through here. So it says, what is the value of Kb for the conjugate base of a weak organic acid that has a pKa of 5? Well, what you need to know is that between an acid and its conjugate base, or its conjugate base and its acid, their pK values, so pKa plus their conjugate base, pKb, so the Kb of the conjugate base to the acid, Ka, or the other way around, the pKa of the conjugate acid to the pKb of the original base, always must add up to 14. So if we know that pKa is 5, that means pKb has to equal 9 to equal 14. So pKb is 9. Now, what is the Kb value? Remember, pKb is equal to negative log of Kb. And that's equal to 9. We're given that pKb is 9. So that means negative log Kb equals 9. Or I guess we don't have to put brackets there. These can be parentheses. And that means Kb has to equal 10 to the negative 9, which means the answer is C. Now, if you're not comfortable with exponents or logarithms, definitely recommend that you guys go check those, as they are pretty important for the MCAT, and they are expected of you. You're expected to know how to use them. All right, let's move on to the second to final question here. It says, an ester is prepared by the method of direct esterification using an esterase enzyme as a catalyst, which with volume modifications will not appreciably increase the final yield of the ester. So let's go through B through D actually first. It says using 2 moles of RCOOH instead of 1 mole. Now, B, this is a direct call to Le Chatelier's principle. Again, very, very important principle in chemistry. If you guys don't know what it is, essentially what that means is if you're going to increase the amount of some reactant on this side, you're actually going to tilt the reaction, so you're going to drive more towards the right, and you're going to create more products of the ester and the water molecule. So Le Chatelier's tells us that if you use 2 moles instead of 1 mole of this product, you're actually going to increase the amount of the product here of the ester. So that's going to be B. So B has to be wrong, since it will increase the final yield of the ester. This one says using 2 moles of RCH2OH instead of 1 mole. Same idea as B. Increase this guy, you're going to increase the right side too. Finally, D, moving RCOOH, moving the ester, so RCOOCH2R from the reaction mixture as formed. If you decrease the amount of this, Le Chatelier's, again, tells us that in order to kind of balance the equilibrium again, we're going to try to fill the gap that's being formed by the fact that we're decreasing the amount of the ester we're forming here. And the way we do that is, well, we're going to use up more of our reactants here to try to increase the amount of ester. So as we remove it, we're actually going to be creating more ester as it happens. So for example, if we have somehow we have a flask like this, and the esters are forming here, and somehow we're siphoning out the ester into like another cup. Well, in this reaction vessel, the reactants think that there's not a lot of esters being formed, so they're going to try to combine with each other to make more ester, and they're going to collect more esters down here as well. So this is going to increase, D by Le Chatelier's principle is going to increase the amount of ester, the total amount of ester. Now, A, using 2 times as much enzyme. Sounds like it'd be a good idea, but it's not going to actually change how you're going to, how much of the final ester you're going to make. Remember, enzymes, they are a kinetic tool. They don't actually decrease or increase the thermodynamics of the reaction. And what that means is it's not going to change the equilibrium concentrations of this reaction. So an enzyme just makes the reaction happen faster. It doesn't actually make it such that you make more or less of the product or the reactant. So even though you can use 2 times, 3 times, a million times more enzyme, it's not going to change the actual amount of ester you're forming in the end, meaning A has to be the correct answer, as it won't increase the final yield of the ester. All right, so this is the last question of the ChemPhys section. This is the last discrete. It says, a person pushes a rolling cart with a force that diminishes with time because the person must walk faster to keep up with the accelerating cart. How much work does the person generate while pushing on the cart? So guys, remember work is equal to force times distance, simply speaking. And in a graph situation like this, that means you just find the area under the curve here. So since this is a triangle, force is 100 newtons, or it gets up to 100. You multiply that 20 meters, and because it's a triangle, got to divide that by 2. And you see that it's going to be 1,000 newton meters, which is same as 1,000 joules, making B the correct answer.